Data center cooling systems are essential for maintaining optimal operating conditions for servers and other IT equipment. As these machines process vast amounts of data, they generate significant heat. Without effective cooling, overheating can lead to equipment failure, data loss, and costly downtime. At the core, data center cooling works by removing heat from the environment and ensuring that the temperature and humidity stay within safe limits. The most common cooling methods include 1. Computer room air conditioning, CRAC, and computer room air handler, CRAH, units. CRAC units function much like traditional air conditioners, using refrigerants to cool the air, while CRA units use chilled water supplied from a central plant. Both systems circulate cool air through raised floors or overhead ducts, directing it toward server racks. 2. Hot aisle, cold aisle containment. Servers are arranged in alternating rows with cold air intakes facing one aisle, cold aisle, and hot air exhausts facing the other, hot aisle. Physical barriers or containment structures prevent mixing of hot and cold air, improving cooling efficiency and reducing energy consumption. 3. Liquid cooling. As server densities increase, liquid cooling is gaining popularity. Coolant is circulated directly to heat-generating components, such as CPUs and GPUs, through pipes or cold plates. This method is highly efficient at extracting heat compared to air-based systems. 4. In-row and rear door cooling. In-row cooling units are placed between server racks, targeting heat at its source. Rear door heat exchangers attach to the back of server cabinets, absorbing exhaust heat before it enters the room. 5. Evaporative cooling and free cooling. Some data centers take advantage of outside air when temperatures permit, filtering and circulating it inside, free cooling. Others use evaporative cooling, where water evaporation absorbs heat from the air, reducing the need for mechanical refrigeration. 6. Environmental monitoring and control. Sensors constantly monitor temperature, humidity, and airflow. Intelligent control systems adjust cooling output in real time, optimizing energy use and preventing hotspots. Together, these systems ensure that data centers remain reliable, energy efficient, and capable of supporting the ever-growing demand for digital services. As technology evolves, data center cooling continues to innovate, balancing performance, sustainability, and cost. Data centers are the backbone of our digital world, hosting countless servers that generate significant amounts of heat as they process and store data. To ensure these sensitive electronic components operate reliably and efficiently, sophisticated cooling systems are essential. At the heart of most data center cooling strategies is air conditioning, which works by circulating cool air throughout the server rooms while removing hot air produced by the equipment. Raised floors or overhead ducts often help channel this airflow, directing cold air to server inlets and whisking away the heated exhaust. In addition to traditional air-based methods, many modern data centers employ liquid cooling solutions. These systems use chilled water or special coolants that absorb heat more efficiently than air alone. Liquid cooling can be implemented through rear door heat exchangers, direct-to-chip cooling plates, or even fully immersive baths where servers are submerged in non-conductive fluids. This approach not only enhances cooling performance, but also allows for higher server densities and improved energy efficiency. To further optimize thermal management, data centers frequently use hot aisle and cold aisle containment. By physically separating the rows of server racks into distinct hot and cold zones, these containment strategies prevent the mixing of warm and cool air, ensuring that cooling resources are used effectively. In some advanced facilities, cooling is supplemented by leveraging outside air during cooler weather, a practice known as free cooling, which reduces reliance on mechanical refrigeration and lowers operational costs. Overall, the design and operation of data center cooling systems are driven by the need for reliability, efficiency, and sustainability. As demand for digital services grows, the industry continues to innovate, seeking new ways to manage heat while minimizing environmental impact.